So, welcome once more. This is the very last video of this topic. I want to look at nucleic naming, and I intend for us to look at the nucleic acid structure, especially the structure pertaining to the double-stranded nucleic acids, whether it is double-strand RNA, double-strand DNA. On nucleic acids, we take a specific focus will specifically on the rules that we call the Chagaf's. And in the Chagaf's rules, the first rule is that in a double stranded nucleic acid, like this one on the screen, this is an example of a double strand DNA. By double strand, we mean that we have one strand we have one strand on the left, and we have another one on the right. So you can be able to, so they are held together by what we call hydrogen running in between here. These lines, dotted lines joining the letters there, those are the hydrogen. So this is an example of nucleic acid, double stranded DNA. One strand is running on this side, and another strand is running on this side. So you can be able to see, and they are joined together by the hydrogen bonds, as I have said. So we are going to look at how do we name this this nucleic acid, and the naming is guided by rules that we refer to as the Chagaf's rules. So the one for the Chagaf's rules is that when we have strands, they will always run in opposite direction. Will always run in opposite direction. To use another word, they are anti-parallel. The two strands are anti-parallel. They don't meet or mix, but they run opposite to each other. So as you can be able to see, in this case, the 5 end is on this side and the 3 end is on the other side. This strand is running from this direction to this direction. The other one is running from this direction to this direction, but they are held together by hydrogen bonds. So you can be able to see these dotted lines in between. They are the hydrogen bonds. So that is the first rule. The two strands are anti-parallel. The two strands run in opposite directions. Secondly, the two strands are complementary. The two strands are complementary. By complementary, we mean that adenine, for example, adenine will always pair with thymine, as you can see. And when the two nitrogenous bases pair, they pair through two hydrogen bonds. You can also see here adenine is pairing with the thymine. A is pairing with T. It is abbreviated as A and T respectively. Adenine will always pair with the thymine. A will always pair with T. And then for the double strand RNA, we can also substitute thymine for uracil. We can substitute T for U. In this case, if we have double strand RNA, T can be substituted with U. So adenine can also pair with uracil. Adenine can also pair with uracil when we have double strand RNA. Guanine. Cytosine will always pair with guanine through three hydrogen bonds. You can see here we have three dotted when it pairs with guanine. When adenine pairs with thymine, we have two hydrogen bonds. When cytosine pairs with when adenine pairs with thymine, we have two hydrogen bonds. When cytosine pairs with guanine, we have three hydrogen bonds. So this means that one nitrogenous base on one end can define the nitrogenous base that will be on the other strand. Finally, due to this specific pairing, the amount of adenine in a double strand will always equal the amount of thymine or uracil on the other strand. The amount of guanine on one strand will always equal the amount of cytosine on another strand. So this means that purines in a nitrogenous base, the purines in a double strand DNA will always equal the pyrimidines. If you can remember what we learned in nitrogenous bases, the purines in one strand will always equal the pyrimidines in a double stranded DNA. In a double stranded DNA, the purines will always be equal to the pyrimidines. So that is the class today on nucleic acid naming. I'll be sending an assignment to your WhatsApp for your own personal exercise. Thank you for listening. Let's meet in the next class.